All right, guys. We finished example number 1 on the back, right? Yeah? Okay. Here is graph number 2. I didn't pass out my colored pencils. I can put them out if you want them, or color code if you've got it. Drop them too. Let's take a look at this one. How many pieces of a line do we have here? 3. I'll get there if anybody wants them. So, I'm going to color code. I'm going to call this equation number 1. Piece number 1. Yeah? What kind of shape does that part of the graph have? A line. It's linear, right? So what is the format for a linear equation? Y equals mx plus b. Well, what's m stand for and y equals mx plus b? Slope. Rise over run. Count it. What is your slope in this picture? 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. So my slope looks like 1. What does the b look like? The y-intercept. Does it cross the y-axis? No, so it doesn't have one, right? No. How do I find it? Keep going. Imagine extending that line, continuing the slope, right? Up 1 over 1. Up 1 over 1. Where is it going to hit? 2. Do you see how I could analyze that graph and identify the slope and the y-intercept? Yeah? So then the equation part would be y equals x plus 2. If you want to write 1x plus 2, that's also okay. Cool? Now, along with that equation part, you have to write the parameters. You have to write the x values that we're using. So we don't want the entire line x plus 2. We only want a piece of it. Cool? Ethan, you with me? So, actually, I need to erase so I can see this a little bit better. Okay? Where do our x's stop? What number are we breaking this off at? -1. Do you guys agree we're stopping it at -1? Yeah? Do we want the x's that are greater than -1 or the x's that are less than -1? Less than, because it's going to the left, correct? So x is less than -1 or equal to y. Because it's a closed circle, we want to include that -1, we make it less than or equal to. Does that make sense? Yeah? Those of you not writing, is it because you already have it done from last class? Yeah? Yes, ma'am.
Can I actually ask a question about last class? If that's okay. Like the this part of it.
Okay, go ahead.
So on the second one, 23. Like when I looked at this, I got this wrong because I looked at it as like an absolute value function that just got like that's where they wanted to stop it. So in that case, like how are you supposed to know that that's actually 2 separate lines?
Gotcha. So the way I knew that it wasn't an absolute value function is because absolute value functions have the same slope on either side. So I would have like a slope of 1 and a slope of -1, or slope of 2, a slope of -2. This one has a slope of 1, but this one has a slope of -1 over 2. So because the slopes are different, that's why it wasn't an absolute value graph. Okay. Cool? You're welcome. Good? Alright. So, are we good with our red piece number 1? Yeah? Alright. Switching colors if you've got them. Open circle line, open circle. This is equation number 2. What kind of shape is he?
Linear.
Linear again. Y equals mx plus b again. What does his slope look like?
1.
1. Up 1 over 1. Up 1 over 1. Good.
3.
Y-intercept looks like it's
3.
3. It actually crosses. You can see it. Cool. So the equation is x plus 3, or 1x plus 3. Feeling comfortable so far? Yeah? I know a lot of you guys had questions on this for your homework. Are you feeling better with it? So far? Okay. Alright. So now, harder part, maybe. Once we have the equation, we also need the parameters. We need to know the x values. Now this one, it has a starting point and an ending point. Yeah? Okay? So that means that x is going to be in between 2 numbers. So set it up so that x is in between two numbers? What two x numbers is it between? -1 and +1. Do you see it? So between -1 and +1. Now on my symbols, do I want them to have equal to's or no?
No.
Why not? Because they're open. Cool? Now when we write this, we don't do a lot of work with this type of inequality where the x is in the middle. But basically every time we write them, we do want the symbols to point to the left. We want them to have both be less than symbols. Okay? Should be -1 is less than x is less than 1. They both go to the left, not one of each. They both go to the left. Okay, that's how we write x is in between those two numbers. Good? All right, one more. Equation 3. Why don't you guys try this one with your partners? And if you feel good about it, try the last one. The last example beneath it. Feel good on it? Yeah?
The line step would be one as well.
So Thomas, you understand how you find the equation better?
Yeah. Oh no, I just totally forgot about the y. So x is greater than or equal to 1.
And then so it's
We have to write out the.
If you feel good on your third equation, try number 3 underneath it.
It's 1, 3, 5. Wait, so it's just y equals 1, y equals 3, y equals 5? Yeah. So then it's 0 included.
Wait, is that close to things?
Yeah. So we have to do the thing where it's sandwiched between two numbers. So write x in the middle, and then 0 and 2. So then it has to be greater than or equal to 0 or less than 3. So like that, it's 0
greater than or equal to x.
0 less than or equal to x less than 2.
In the third one, you've got a bunch of horizontal lines. Is that y equals mx plus b? No, it's just y equals a number. Like a hoy, buxmoy, for those of you that didn't learn that in algebra 1. Yes.
For the two signs.
Yeah, I remember horizontal and vertical because each has like the line.
Really?
That's the trick. I don't know.
What?
Wait, no.
It's definitely just the bracket. It's used in other things.
I agree with that. From all the stuff that we think.
What is the bracket called?
A brace.
A brace?
I always thought it was like some weird, like, I don't know,
There could be.
Latin.
There could be. One and it's not. I just don't know what it is. All right, guys, help me out. Fact number 2. What's the equation for my third piece?
Y equals x plus 1.
X plus 1. And the parameters for that part?
X is greater than or equal to 1.
Awesome. I saw a couple people, can you guys look up here? Ethan and Nani, stay with me. I saw a couple people write this as 1 is less than or equal to x. That is also correct. It depends on how you see it and how you want to write it. They're both correct. Okay, I usually write it with the x first, but you don't have to. Now, I want to challenge all of you, because I noticed this on a lot of papers. Don't write this as 3 separate equations. This is one big function. So give me a brace or a squiggle or whatever fancy word it could be called, and put y equals or f of x equals in front of the whole thing. Okay, one big equation. Good, instead of 3 separate ones. In number 3, same idea. We're going to have 3 big equations into y equals. Okay. What was this guy's equation? Just y equals 1, just a horizontal line. And what were its parameters?
0, 0 to less than or equal to x less than 2.
Awesome. Between 0 and 2, close, so equal sign on the 0, open, no equal sign on the 2. Both of those inequalities should be less than. They go to the left. What is this guy's line?
3.
3 parameters?
2, x, 4.
2 to 4. Nice. Awesome. And the last one?
4.
From 4 to 6.
And then it's 5.
And it's 5. You feel good? Yeah? Alright. Awesome. Okay. Moving on to our new notes for today. Do you feel like you'll be better on those last 2 from the homework? Now that we did those more in depth? Yeah?
This is 4.
What?
This one is 2.
Should be 2 to 4. 2 to 4. Cool. Alright.
And then
Okay, so as we get into our next set of notes for today, if you have colors, I'm going to color code. I do think it's a little helpful. If you want to come borrow probably 3 colors again, if you don't have them and want them, you can grab them right now. Okay. What we're going to be talking about today is analyzing graphs. And I apologize in advance because I know this beginning part is really not interesting. It's tedious. Go grab which one. The first few things we do is very tedious.
you only got
So the first thing we're going to be doing is looking at symmetry of graphs. It's very tedious. It's not very interesting in front. It's one of my least favorite things I have to teach. I'm sorry. Cool? I'm just throwing that out there. All right. So first, what are the different types of symmetries we could have? What do they look like in pictures? Okay. So one type of symmetry we have is y-axis symmetry. Okay. That means that you can fold the picture along the y-axis, and it's a mirror image on either side. Okay. So draw with me, if you would, a little picture of what this could look like. Any shapes come to mind that would have y-axis symmetry? A parabola? Do you guys agree a parabola does? Yeah. So maybe we'll draw a parabola like this. You can see it has y-axis symmetry. It folds along the y-axis there. Well, I'll tell you when I color code. It's going to be in a little while. Feel free to use colors if you want, but I'll tell you when I really want to color code. Now, what's interesting about the y-axis symmetry is the points. So if we had a point over here, let's say that point is the point 2, 1. Okay? When it's symmetric over the y-axis, that means it's also going to have a mirrored point over here, right? What would that point be? Negative 2, 1. What changed? The x value. So, what we're going to be doing today is not only looking at the graphs, but looking at an equation, and without graphing it, without using our calculator, we're going to be able to determine what type of symmetry it has by doing an algebraic test. So when we want to test for y-axis symmetry, we're going to plug in a negative x, because that's what changed here, was that the x's changed signs. Okay? So when we get to the symmetry test, we're going to plug in a negative x to test for y-axis symmetry. Okay? Another type of symmetry is x-axis symmetry. That would be when you have a picture that folds along the x-axis. Not a lot of functions are x-axis symmetry, okay? But maybe we could draw a picture of something that's not a function. Maybe we could draw, how about a sideways V? Not that we see those graphs very often, but maybe we could. Okay. You can see that that folds along the x-axis and has x-axis symmetry. Cool. Let's look at a point on him. Let's say this point is 2, 3. What would his reflection be? 2, -3. So what changed there? The y, the x stayed the same, the y changed, right? So when we do an algebraic test in a few minutes, to test for x-axis symmetry, we plug in a -y. Do you see how these are a little tricky and backwards and confusing? Yeah? To test y-axis, we do -x. To do x-axis, we do negative for the y. So it's kind of backwards from what you expect. Cool? Okay. The last type of symmetry is called origin symmetry. And this is probably new, although technically we did do it a little bit back when we did sine and cosine graphs. We'll talk about it very briefly. Origin symmetry is when it rotates 180 degrees around the origin. Origin symmetry rotates 180 degrees around the origin. Y equals x, a diagonal line. Yes, that would work. I'm going to do one a little bit more interesting. I'm going to do a x cubed graph. A few seconds to draw that picture and we'll talk about its symmetry. Notice how this graph, it's x cubed, it starts down in the bottom left, goes up, goes through the origin, dips down a little bit, and then goes up to the right. Right, so it's like this kind of shape, right, with some bumps. If you rotate it 180 degrees, oh, it's a little off, sorry. But it's the same picture. Cool. How can you do that? Because I know you can't just magically turn the pencil on your paper, right? The drawing on your paper. How do you tell if your graph is rotational? Say it again. That's all you have to do. That's exactly right. You take your paper and go like this. If it's the same picture, that rotated 180 degrees. Cool? So start with what? Here, I'll go back to my original. There we go. Take your paper, turn it upside down, and compare it to mine. Is it the same picture? Starts in the bottom left, goes through the origin, up to the top right. That's the same picture. Cool? Okay? So that's how you can see rotational symmetry. Okay? Or origin symmetry. When we talk about its points, let's say we looked at this point over here. Let's say that's the point -1, 2. What would his symmetrical point be on the other side? +1, -2. Exactly right. +1, -2. What changed there? Both of them. When we do origin symmetry, we plug in a -x and a -y. Cool? Okay. So, the next part you don't have on your notes. I want you to just look up here with your partners. Discuss these four graphs and what type of symmetries each one has. Chat.
First one is X. Wait, hold on. This graph. Which one are we saying is this? Okay, so it's the Y symmetry for the first one. The second one is, I don't know, the bottom right is X symmetry. The one on the bottom left is the origin. I don't think it's not symmetrical.
The one on the bottom left, right is its axis, and the one on the bottom left.
All right. Talk to me, guys. Did any of these have x-axis symmetry?
Bottom right.
Bottom right? Awesome. Did any of them have y-axis symmetry? Top left. Those look a lot like the pictures we already drew, didn't they? Alright. Happens every time. Do any of those have origin symmetry? Bottom left. So what about the top right?
No, it's not.
Cool. All right. If you wanted to add those pictures to your pictures, you can. I feel like they're kind of the same as what we already drew. My bad. Cool? All right. So now we're going to do it without a graph. Okay? Now I have an equation, xy equals 16, and I want to test it for symmetry. Here is where I'm going to start to color code, if you want to join me. Okay. So to do y-axis symmetry, I'm going to use one color. What do I do to test for y-axis symmetry? Plug something in. Careful. Negative x. Cool. It's the opposite of what you would expect, right? So when it's y-axis symmetry, we're going to plug in negative x. Cool? So with me, here we go. Plugging in negative x. I always plug in using parentheses. Why don't you just simplify that? How does that simplify? Nope, just simplify. What is negative x times y? Negative xy. Good, that's as far as you gotta go. Negative xy. Now the question you want to ask yourself is that exactly the same as what we started with?
No.
No, then it is not y-axis symmetry. Okay? This is not equal to the original. So no, it is not y-axis symmetry. Kind of, sort of? Okay. I'm going to switch colors. And test for x-axis symmetry. How do I test for x-axis? Negative for the y. Good. Again, I use parentheses because I don't want it to look like x minus y. It's x times negative y. Simplify that. What do we get? Negative xy equals 16. Is that exactly the same as what we started with? No. So is it x-axis symmetry? No. All right, last one is origin. How do we test origin? Negative x and negative y. You gotta do both of them. So when we plug those in, simplify it, we get xy equals 16. Gracias. Is that exactly the same as what we started with?
Yeah.
Yes, finally we just proved something. We proved that it has origin symmetry. Cool.
So is this on the board for your symmetry sheet? You also have different names for them underneath. Are we gonna have to know about them as well? Like,
Yes, that's coming. Cool. Equal to beans? Right. Up next, we're going to take 3 more equations, get some more practice with this, by testing x, y, and origin symmetry. Okay? you'll notice the directions want you to pick. Is it only x-axis, only y, only origin, or is it both axes and the origin, or no? Cool? I'm going to color code because in each of these boxes, you have to do all 3 tests. You have to write really small, and I was going to color code to try to make it a little easier on my eyes. So I'm going to do all x, all y, and then all origin. 3 different colors. Cool? Questions? Good? Alright. So let me be consistent. What color did we use before? Y-axis. So let's do y-axis first. I'm going to use my red pen. How do I test for y-axis symmetry? Plug in negative x. Alright. So again, writing small, color coding if you're able, or want to, I guess I should say. Plugging in negative x, using parentheses when we plug in. Simplify. When you square a negative x, what do you get? Positive x squared, right? The squared is still there, but it becomes positive. Yeah? Is that equal to exactly what we started with?
Yeah.
Yes? Then that means it does have y-axis symmetry. Cool? Let's do x-axis symmetry. Grab a different color. How do we test for x-axis symmetry? Plug in negative y. Good. Remember, they're backwards from what you'd expect. Simplify that. What do we get when we do negative y to the 4th? Positive. Good.
What would this look like? Oh my god.
I can't remember what this one is. It's funky.
Yeah,
Cool.
I want to see it.
It's sometimes like shapes that have more than one symmetry, maybe like an oval or a circle sometimes might have more than one symmetry. I don't remember exactly what this graph is though. 'Cause it's-
Yeah. Really weird. Because it has all 3.
So is this exactly the same as we started with?
Yeah.
Yep. So then we have x-axis symmetry. Cool. Alright. One more color if you've got it. Origin. Plugging in
Negative for both.
negative on both. I know, it's like no space at all. I don't think so, but I don't. Can't think of a counter example. I'll ask it lunch. See what my friends say. Okay. So, how does this simplify? Does it give us exactly what we started with?
Yeah.
So this one has all 3. Cool. So this would be kind of, sorta? Alright. So let's take a look at number 2. Again, I'm going to color code if you want to join me. Let's do y-axis first because we did y-axis first last time. So we're going to plug in negative x. Now this one, it doesn't have a y equals, it has g of x. Is that the same thing?
Yeah.
If you want to change it into a y equals, you can. Plugging in a negative x. simplify that? I can. What's a negative 12 over a negative x? Positive 12 over x, right? Because each one's just one term. So we can divide them and get positive 12 over positive x. So then, it is not the same as what we started with, so it is not x-axis. Sorry, mine's too messy. All right. Switching colors, let's do x-axis. If you're working ahead, back up to this one with me, it is a little different. X-axis, what do I plug in? Negative y. Again, this one doesn't have a negative or a y, but I changed g of x to be y, so it's like negative y on this side. Cool? Now, in this one, because the y is in by itself, and up here in my original equation it is y by itself, you need to do some work here, because we can't simplify on the right side, can we? No? But I want you to get rid of that negative 1 on this side. How can I get rid of that negative 1? Divide or?
Multiply by that.
Either way works, right? If I divide by negative 1 or multiply by negative 1, what's a negative divided by a positive divided by a negative? A positive, good. And dividing by 1 doesn't change anything, does it? Okay. So when I divide this by a negative 1, all it does is change it to a positive. Is that exactly the same as what we started with? Nope. All right, let's try origin. Again, this one's a little different, so watch it with me. If you're working ahead, kind of back up. Guys in the back, make sure you're watching this, okay? What do we test for origin? Negative, both, good. Negative x and negative y. Plugging that in. Alright, couple things here to work on. Simplify. What is negative 12 and negative x change?
12 over s.
Positive, right? So that makes it positive. Then, I said a minute ago that when there's a negative in front of the y, because our equation was just y by itself, I want you to make this just y by itself. So what would you do? Multiply or divide by negative 1. What does that give me as my new equation? Negative 12 over x. You're absolutely right. So dividing it by 1 doesn't change it, but dividing it by a negative changes it to a negative answer. Is that the same as what we started with? Yes. So we have origin symmetry. So it is C. It is so much work. That's why I hate these problems. Cool. Wouldn't it be nice if I said, here's a calculator, just grab it on your calculator and see what picture it is?
We do.
If it's on the calculator part of your quiz or test, yes. If it's not, or it asks you to do the symmetry test, you gotta show your work for it. Cool? Sorry. Alright. Let's take a look at number 3. Do you want to try this on your own / with your partners? Or do you want to do it all together? Try with your people? Try with your people. Go team, you can do it.
So y-axis you plug in is negative x. Wait, hold on. No, you have to do it weird. So that you have to negative. Yeah, negative parenthesis negative x to the fourth. The fourth makes it positive. So it's a negative, it goes back to negative x. Negative x fourth plus 3. So that thing, big old check. Alright, next one. So the one, it's not gonna work.
It wouldn't work if you really went. So yes, no, no.
But I wanna ask her if we just write down the initial equation and we can tell just by having to write everything down.
I think since these are notes, it's really up to you, like, how you put it together, like.
And that's what make that
All the time, huh? Like, all the time. What else?
What's up?
Would it be okay if we got a test for twice we just wrote the initial equation and make a negative without?
I probably want to see you simplify.
Alright.
It's under your second. Yes, sir.
Exponents first.
All right. Let's check. How did this one simplify?
That worked out.
Negative x to the fourth plus 3. Because, make sure you check this, guys. Exponents first makes it positive. The negative just came down in front. Yeah? So was that the same?
Yeah.
Yes? This one's y-axis. Cool. When we plug in negative y, this is another question I got. What are you going to do here? Divide or multiply -1, same thing. Do you divide just this guy?
No.
Both of them. Cool. So it would be x to the fourth minus 3. Is that the same? No. I know this is painful. I promise. We're almost done with the hard part, or the tedious part. Give me one sec. Here, this guy first makes it positive, but the negative comes down. Does it? Oh, it turns into the green?
Yeah.
You're right, it turns into the green. So is it the original?
No.
No. So this one was only y-axis, so it is B. Question, sorry.
We tried to graph a function on the method and number 1, I didn't have x symmetry or.
Did you put a plus or minus in it because you did a fourth root?
There's a plus or minus?
Because you did a fourth root, I think so. Was it like this? No. All right, so one more thing about these annoying TD symmetries. I guess is what they are. They have some special names, and Aaron alluded to this. I have it up here on my yellow note up here for you. Okay. To do if a function has y-axis symmetry, we also call it an even function. Y-axis symmetry is also called an even function. Origin symmetry is called odd. Can anyone think of a clever way for us to remember that?
Origin is odd.
Why is that obvious?
Because origin's the weird one.
They both start with
Because they both start with O.
Origin's the weird one. So
Obvious. Origin, odd, and it's odd looking maybe.
yeah, no, I mean, it's just the weird one. It doesn't.
The weird one that you have to like
Yeah.
rotate. That's a good idea too. Okay. Alright. So origin is odd, y-axis is even. X-axis symmetry. He does not have a special name because when you have x-axis symmetry, does it pass the vertical line test? No. Cool. So we usually don't have a special name. Okay. So looking back at these three examples that we just did, real fast, give me new names for this. This one had y-axis symmetry, so we could also call it even. It had x-axis. Does that get a special name?
No.
Origin. Odd. So this one is even and odd. Number 2 just had origin, so we could call it odd. I heard it from like 2 people. Good. Ethan, Celis, you guys good?
Yeah.
Last one, y-axis. We could call it even. So you have to read the directions and read what the question's asking. Sometimes I ask you, is it even or odd? Sometimes I ask you what kind of symmetry it has. X-axis, y-axis, origin. So just make sure you read the question it's asking. Cool? On to much easier things. X and y intercepts. Oh, breath of fresh air. You've been doing X and Y intercepts since Algebra 1. Yeah? So, maybe even from before then, you're right. X intercepts. Who remembers how to find it?
Look at this graph.
What if you don't have a graph? What if you only have the equation? The x-intercept is not the t, that's the y-intercept. Plug in 0 for y. To find the x-intercept, you plug in y equals 0. To find the x-intercept, you plug in... Sorry, I said that wrong. To find the y-intercept, you plug in x equals 0. Cool? So notice, just like the symmetries were backwards, x and y intercepts are backwards. To find the x-intercept, you plug in 0 for y. For the y-intercept, you plug in 0 for x. See how they're backwards? Okay. X-intercepts also have some special names. What else can they be called? Roots, zeros, and solutions. Nice. Roots, zeros, that's probably the one we use a lot. And solutions. Now, I am really picky. I know that surprises all of you. But when I ask for an x-intercept or a y-intercept, you must write them as ordered pairs. Okay? If I ask you for the x-intercept and you say 3, I'm going to say, great job, partial credit. Okay? You have to write it as a point, as an ordered pair. If the answer was 3, you would write 3, 0. Okay? Whatever your x is, 0 for the y. Cool? For a y-intercept, the 0 you know is going to be your x number. You're finding the y. Always write them as points, ordered pairs. Cool? All right. For our next part, we're going to need calculators. Who needs to borrow one? For Willie and Aaron, por favor. Anybody else? Grab your calculators if you don't have them out for me. Yeah?
I have a question for you that I think we should talk about. Could you tell me the ways to solutions? What is it? And it's easy to do. We have to find pair of solutions or
Like the y with the bracket, and then you get you 2 different equations.
It gives you like a lot of tools.
Yeah.
Sure, yeah. I'll forget in 30 seconds to remind you, alright? Yeah, but no Y equals in front,
Oh,
I'll do that,
okay.
yeah. Alright, so, we're gonna do these on our calculator, but I bet, you know what guys, you probably know what this graph looks like. What is this graph gonna look like? What kind of shape is it? It's an eyebrow, right? Can anyone describe the transformations of the eyebrow?
1 to the left 4.
Perfect. All right. But I am going to let you use your calculators because I'm so nice. So in your calculators, guys in the back, you with me? We're doing square root of x plus 4. If you're using a TI-83, one of the older calculators, you need to parenthesize the x plus 4 inside the square root. I don't think anyone in here has an older one. Okay. For the newer calculators, if you have an 84 or higher, you gotta get your cursor out of the square root and do -1. Cool? If you do zoom 6, that's a good graph. It goes -10 to +10 on the x and y axes. Compare your picture to mine before you start drawing. Maddie, check your picture. Is yours the same as mine? It can be symmetrical. Like, if you're saying
Algebra 3. Hell, yeah, too.
There's x squared, so any number will just.
Did you show the
There's x
All right, so drawing this graph, you can use your table, second graph, second table to find some good points. Try to put 3 or 4 points on here as you're drawing it. Join me, draw, draw, draw. Did anyone get a different picture? Anyone get an eyebrow going down? No? Okay. All right, so here's my eyebrow. Now using your graph, can you tell me what f of 5 is?
2.
2, how'd you know that?
Because it's a point.
Okay, so it's a point, which point? How do I know which point to look at?
Go to x equals 5
Good, x equals 5,
and go up until you get.
and find the point is 2. Gorgeous.
So if there wasn't a point there, you just put the closest approximation to wherever it is on the line.
If there was an open circle or something, there was no answer there, you would put undefined. If it
Right.
wasn't an exact pretty
Yeah.
decimal, then you would just like, or whole number, you would just kind of round
Okay.
1.2 or something like that. Cool. All right, the y-intercept. Where do we think the y-intercept is? 1? Wrong, cross credit.
0, 1.
0, 1. Good. For a y-intercept, you have to write it as a point. It's where it crosses the y-axis.
And then -3.
X-intercept, partial credit.
-3.
-3, 0. Good. How are we feeling? Does this make sense? Alright. The next thing I want you to do is we're going to take the same exact equation, but we're going to do it algebraically. Instead of using your calculator, because part of your homework tonight, your quiz, your test, I'm going to ask you to do this algebraically without using a calculator. So, same formula. How would I find f of 5 algebraically?
Plug it in for that.
Plug in 5. Go.
Oh, I did that first.
Oh, awesome. That's cool too. So go ahead and show your work, plugging in 5 algebraically without a calculator. Add a calculator, f of 5, you're plugging in 5 into the equation. How do you find a y-intercept?
0 in for x.
0 in for the x. Did I give you papers on it?
No.
You good? You good by hand? Did it work on your phone? Oh. Just plug it in my hand. Cool. This is at the bottom of your page. It's the same equation. Just doing it by hand. How are you going to do the y-intercept?
Plug in 0 for x.
0 for the x. Good. Will I give you minutes? And the last one's probably the hardest. How do I find an x-intercept? 0 for the y. Good. Alright guys, we already know the answers because we got them at the top of the page, but tell me, what did you get for f of 5?
2.
2. It's 5 plus 4 is 9, square root is
3.
minus 1 is 2. I had someone ask me last period a really good question. They said, what about plus or minus? When you square root the 9, don't you need plus or minus on the 3? The answer here is no. And here's why. This is confusing for a lot of students. When the problem given to you already has a square root in it, they will tell you whether they want the positive, the negative, or both plus or minus. If I wanted both, I would have had to put a plus or minus in the formula in front of that square root. Okay? Here, since they didn't put a plus or minus, they only want the positive. Sometimes they will put a negative in front, and then they only want the negative. Okay? The difference is when you are solving an equation, and you add the square root to it, that's when you have to put the plus or minus. Do you see that difference? Okay? So if the square root is already in the problem, don't add a plus or minus to it. If you are solving and you put the square root in, you have to put the plus or minus. Cool?
I know for the x and y intercept, it has to be ordered here in the answer, but when you find like f of 5 and you want us to write it in order
You don't need to. You just need to tell me just the 2. In fact, I think just 2, I don't think you can write it as ordered. You can just say 2. Cool? All right. For the y-intercept, you plug in 0 for x, and what did you get?
0 for 1.
0, 1. Oh, it's a point.
Yeah.
Sorry. I thought you said 0. I was like, it's 1. 0, 1. There we go. Cool? Guys in the back, you're distracting me. Can you hush, please? All right. Last one, x-intercept. This one's probably the hardest, so let's do this one together.
Square
Plug in 0 for the y. How do I solve it? Add the 1 first. Add the 1 first. Then we square both sides. When I square both sides, I'm going to put a star next to that. That's something important we're going to talk about in just a minute. When I square both sides, what do we get?
1 equals 1 plus 2.
You with me so far? solve it.
It's minus 3.
Subtract the 4 gives you minus 3, or negative 3. Cool? Alright. Now I put a star next to that step of squaring both sides, because when you square both sides of an equation, there's something extra we have to do. Anybody remember what it is? Check for extraneous solutions. This only happens when you square both sides. Okay? It's only when you square both sides that this is an issue. Okay? How do we check for extraneous solutions?
The answer you got for x, that comes 4x.
Good. You're going to take this negative 3, plug it back into this original equation that we were solving, and make sure it really does give you 0. Okay, or it really does equal whatever it's supposed to equal on the other side. So plugging this back in, whoops, grab the equal sign. What's negative 3 plus 4? Negative 3. 1. Square root of 1 is?
1.
Minus 1 is?
0. We're good.
So good. This one checks out. This one works. But you'll see ones in your homework and potentially on a quiz or test where it doesn't check out. Okay? Final answer, just negative 3?
0.
Negative 3, comma 0. Good. Okay, math? All right. Did everyone get the second page I passed out? Yeah? All right. Then in the interest of time, we're going to streamline. We're not going to do all of these problems. We have 8 minutes left. Cool. So we're going to streamline. Do you feel comfortable taking this equation, typing it in your calculator, using the table to graph it? Guys in the back, stop talking. It's so distracting to me when you're sitting back there talking the whole period. Cool? Thank you. All right. Do we feel comfortable doing that in our calculator? Yeah? Second table, graph plotting points? Yeah? All right. Do you feel comfortable without a calculator doing f of 2?
Yeah.
What would you do?
Go to the 2 on x.
Without graphing it, without your calculator, what would you do?
Plug it in.
Plug it in. Cool? Without a calculator, without the graph, how would you find the y-intercept?
0 for x.
0 for x. Remember to write it as a
Ordered
pair as a point. Good. The x-intercept, this one's probably the hardest.
0.
Let's do this one together. How do we do it?
0 for y.
0 for y.
But the extraneous solutions apply to treating it as well.
No, it's actually only when you square it. How do I solve this? It's not a SOAP because this one's not a cube. How factor? GCF and X
Oh, that's right.
first. Cool? You have to GCF out the X first. Bless you. It's going to be really important that you're comfortable with your factoring moving forward. So, memo to you all right now. Don't feel good on factoring. Now's the time to start coming in for help. Okay, come see me today or Friday if you need help with factoring. When you GCF it out, what's left over?
X squared minus 1.
Is that a dose, a difference of
Yeah.
squares? Yep, you can factor it as a dose even more. Or if you didn't see that, you can solve it with square roots. But when you square root, what do we need? Plus or minus, because you put the square root in, you need the plus or minus. Cool? But if otherwise, it does dose. How does it dose?
X plus 1, x minus 1.
Awesome. And then you've got your x that came down in front, 0. So what does that give me for my answers for x? Perfect. 0, negative 1, and 1. There are 3 answers because...
There are 3 x-intercepts.
Because there's 3 in the exponent.
Because it's an x cubed. Yep, that's it. Not that anything you said was wrong, but that's why. Cool? Alright. So 3 x-intercepts, how do we write them?
Ordered pairs.
As ordered pairs. 0, 0, negative 1, 0, and 1, 0. I don't care the order you list them out in. One thing I do care about though is those are points, correct? Do we use unions for points?
No.
No, you only use unions for like domain and range on intervals, not on points. So please don't give me a U on points. Cool? All right, streamlining, remember? Just take a look at the next two. I think I actually want to do number 2 first. Cool? Just so we can practice putting this in our calculator. How do I put that in my calculator? Everybody remember? Parentheses. When there's more than one term on top, you need parentheses. More than one term on the bottom, you need parentheses. Cool? This is a crazy looking graph. Is that matching what you guys are getting? This crazy thing? Yeah? Use your table to get some good points. There aren't a lot. There's a couple good ones in there. Basic shape's also good enough. Ooh, I see 2 error messages. What is going on with those error messages? Vertical asymptotes. Good, vertical asymptotes with the error messages. And it looks like it also has a horizontal asymptote, doesn't it? Doesn't it look like it's going really flat to the right and to the left? Cool. I think it has a horizontal asymptote. I think it's at like 2-ish. It's a little hard to see. We haven't learned how to graph this by hand yet, so I recognize that. So you've got these like swooshes up in the top left corner and the top right corner. And then like a parabola kind of shape in the middle. This basic shape, good enough. Cool. If I asked you without a calculator, I know you can do it with your calculator. If I asked you without a calculator, how would you find h of 3? Plug in 3. Awesome. Remember your order of operations?
9, 15, 20 divided by 5.
20 on top, and what was the bottom?
5.
5. 9 minus 4 is 5, so I get
4.
4. Cool. Does that match with our picture?
I don't.
How do we know? What do I mean by that? How does it match? How do you know? Okay, where am I looking at the graph for h of 3? 1, 2, 3, and my point is, it's at 4, right? It's in my table as well. X was 3, y is 4. Do you see it? Yeah? Okay. Alright. The one we skipped that we didn't get to there had absolute value in it. Do you guys remember how to get absolute value on your calculator?
Yeah.
What do you press?
Math.
Math, and number 2, num.
Yeah, number.
Cool, you might need that later. I can't remember. I'm actually going to be amazing for once in my life. I'm going to pass out your homework.
Thank you.
I know, I'm like the nicest teacher ever. Okay? On the back of your, might give me 2 seconds. On the back of your notes page, it's just domain and range practice. We didn't have time to get to it, but if you feel like you needed help after that homework last night with domain and range, feel free to look at those graphs. I'm happy to check them for you. You can text me with questions, whatever. Cool? Okay. So coming back, it's homework. Please be working on your vocab list and study guide. The vocab list is 30 words. That is so meager. Please make sure you don't stay before the last minute. Okay? Add-ons are due by Wednesday next week. There's a quiz Wednesday next week as well, so please start studying for it. Cool? Thank you for the extra minute. I'll see you guys on Friday.